What's good, everyone, and welcome back to another video. Today I'll be doing a LeetCode problem, specifically on DFS. Once again, I'm going to be reading the prompt, explain it, write out the code, explain the code, and then just talk about the time and space complexity. Okay, so question 94, binary tree in order traversal. Given the root of a binary tree, return the in order traversal of its node's value. This is a very, very simple one. If you've seen my video for BFS and DFS, or you just already know the BFS and DFS, the question, all it's asking is just for us to basically implement the in-order traversal. Which, by the way, the DFS has 3 of them: pre-order, in-order, and post-order traversal. But this one, all it's asking us is just implement the in-order. If you guys don't know, for a binary tree, in-order traversal means that for every node, you want to traverse the left subtree into visit the node itself, and then you want to traverse the right subtree. So right. On a binary search tree, this prints the value in sorted order, but the problem works for any binary tree. And also, we're returning a list integer with the values in that order. Okay, so what I'm going to be doing is I will basically do a recursive solution. And oh yeah, LeetCode gives us the tree node. So let's just first import Java array list. Oops. There we go. Boom, boom. And import Java list. Now, right here, I want to first have a list. We're going to call it result. New array list. Well, before I continue, I want to write a helper function, actually. And we're going to call it in order helper with the tree node and list integer result. Perfect. Let's do a base case. This one is going to be if node is equal to null, then we just return. This would be the base case, which basically means that there's nothing to traverse, so just return. Now, first, I want to, like I mentioned, you want to do left into visiting the node into right. So I want to traverse left subtree first, which is going to call itself in order helper with the node left and result. Afterward, you want to do visit current node, which is just result.add with the node value. And then towards the end, you want to traverse the right subtree. So to do that, it's the same thing, in order, calling itself, but this time it'll be node right with the result. And that's basically done with the helper function. So for this part, I'm going to call it in order helper, and we're going to start at root with the result and then towards the end, you just return the result, and that's it. Let's run it. Yay, all the cases work. Submit. Perfect. There we go. Easy peasy. Pretty good. So let me explain it line by line. What we have here is this is the method LeetCode calls. Right here we have the result. Result is the list where we're going to store the in order sequence. So right now it's empty. This part is where we call a helper function, which is the in order helper, and it's going to start at the root, and you just want to return the filled list. For this part, what we have here is node is the current node we're processing, and then we have the base case, which is if node is null, which means there's nothing to traverse, then just return. Now, for this part, we have the first recursive traverse the left subtree, basically. This will keep going left until it hits a leaf. Once you finish the left subtree, we visit the current node that we're at. And by visiting, all it means is we're adding the value to the result list. So that's why we have result add node value. Finally, we recursively traverse the right subtree. So that order, you can kind of see it. It's left, node, and then right. It matches the in order definition. So in recursion, the order of these 3 lines is the traversal order: left call, add current, right call. And that's basically it. So, and then before I show you the example, let me do a time and space complexity real quick. Okay, so the time complexity is big O of n, because we are visiting each node exactly once. This right here, the result add, it's just gonna be big O of 1, because all we're doing is for example, like this, you're just adding it and that's it. But we do have to visit each node at exactly once. Now right here, space will also be big O of n. Result list uses space to store all the node values, so that's why it's big O of n. Because the n is gonna be like, sorry, I should probably write this out first, don't I? N is number of nodes. There we go. All right, so now I will show you an example, and let's use example 1. Let me just delete this part first. Oops, let me delete this. Add the space. There we go. Okay, so let's first look at example. Let's just look at example 1, which is we have the root with the input, the output, and then we have what it looks like. So if we look at it, the root node 1 dot left is pointing at null. It has nothing. But 1 dot right has a 2, and then 2 dot left has a 3, 2 dot right is a null, and then 3 is the leaf. So left or right is going to be null. We expect the in order left node right to be left of 1 is nothing, and then visit 1, then we do the right subtree, which is going to be with 2. So let's start tracing the recursion. So first things first, you want to call the in order traversal. Oh, by the way, result is empty, by the way. So now we want to call the in order traversal, which is going to be in order with the root equal to 1, right? Traversal's right here, by the way. Yeah. In order traversal with the root being 1. Now we call the in order helper, which is 1, and result. By the way, in order helper is right here, the root and result. So when we call the in order helper, which is in here, you want to know that the node is basically 1 and not null. So first, in order helper dot left, 1 dot left, which is right here, node equals 1, so 1 dot left. 1 dot left is going to be null. As you can kind of see when you look at it, 1 dot left is null. So when that happens, you basically just return immediately, because node is equal to null. So just return immediately. That means the result is still going to be empty. Now, because we completed this part, now we go here. Result.add the node value. The node value is 1, so we add the result into 1. So that's it. And then afterward, you want to do the in order helper for 1 dot right. And that's going to be 2, by the way. So it's going to be 2. Now, when we look at it, we call 2, which means the node is going to be 2, and it's not null. Again, we want to do the number 1 part, so it's going to be 2 dot left. And 2 dot left has something, which is in order, which is going to call the in order 3. So this time, now we're going to call the in order helper for 3. So change this to a 3. Again, not null. And then change this to a 3. And then oh yeah, by the way, we don't need this anymore. So now we're gonna start at 3, and we're gonna do this again, right? So over here, 3 dot left is null, so just return it. Now we add the value for 3. Now we're going to do the traversal of the right for 3. So 3.right, again, it's going to point at null. So since it's null, you just return it, and then you're done. Now once you're done with node 3, we return back to node 2. So now you want to visit 2, and that with the 2, it's basically tells you, hey, the left is done. Now we can do this part, which is going to add the 2. So add 2. And afterward, then you check the right side for node 2. And since node 2 right side is null, you return it immediately. And that's it. Now all the calls are done. So this will show you the result. Final result. And once you're done with all of these, you're going to basically, this will be done. And then you just return the result, which will be this. And that's how you do it. Anyway, that should be it. I want to do, example 2, but this one, you can kind of do it yourself as well. As long as you follow this code itself, there should be no trouble. If I do the example 2, the video is going to be pretty long. So, yeah, that's basically it. And yeah, I explained the time and space complexity. Thanks for watching.